Okay, so we're going to start week 2 off, which is our bioenergetics week, by talking about substrates and energy production. Kind of two categories of things that we're going to talk about. We're going to talk about substrates, and then we're going to talk about how energy is produced. And so when we talk about substrates, we're basically talking about what do we use to help us generate or create energy in the form of ATP. And so there are three main things that you're probably aware of. One is carbohydrates. So carbohydrates are just sugar. The most common one that we use is glucose, which is just 6 carbohydrates linked together. We can take these glucose, and we do take these glucose molecules, and we can link them all together, and we create something called glycogen, which is the storage form of glucose. And this is found primarily in the liver. You also have glycogen in your muscles. Now, for every gram of carbohydrates that you have, you can produce approximately, or that equals approximately 4 kilocalories. Next, we have fats. And again, many different types of fats, but the body focuses or uses primarily triglycerides. And what that is you have something called a glycerol molecule that has 3 fatty acids attached to it. And these fatty acids are just chains of carbons. Okay. And we'll talk about later how we break these chains of carbons into pairs. All right. And fat is found in adipose tissue, and we can take from 1 gram of fats, we can actually generate 9 kilocalories. There's that much energy in there. So more than double what we find in carbs. Then we've got proteins, which are chains of amino acids, and amino acids have a lot of nitrogen in them. We don't actually use proteins for a lot of energy. We focus on carbs and we focus on fats, or we rely on those. We use proteins for other things. But in order for us to use protein as an energy source, we have to convert them into glucose or fat. And so we call this process gluconeogenesis or lipogenesis. However, just like carbohydrates, we don't produce as many calories, or we can't get the same bang for our buck out of proteins that we do with fat. So 1 gram of proteins equals approximately 4 kilocalories. Now, when it comes time to producing this energy, we want a controlled, consistent rate of release, and that's just to help us be efficient. If you've taken 220 from me before, one of the things that I really kind of focus on, or say several times throughout the semester, and I'll say it here in exercise physiology, is we don't want our body to work too hard. We don't want it to work too little. We want it to work just right, kind of that Goldilocks idea. And so we want to be as efficient as possible. Now, the rate at which we produce energy is determined by 2 things. How much substrate do we have? So how many carbs, fats, proteins do we have? And how active are the enzymes that are needed to take these substrates and ultimately use them to create ATP? Okay, so if we have lots of substrate, then we can produce a lot of energy, okay, going down a specific pathway. All right, the other thing is with enzymes make things go faster, okay? And so it lowers that threshold. And so if you look at this figure here, and this is using the idea of phosphocreatine, which we'll talk about on the next video, I believe. In order for a reaction to go, we have to we start here, but we have to kind of add the energy so that chemical reaction can start, right? So just like you can't start an engine without there being gas in it, we've got to do that. We've got to kind of give it the gas so that it can do what we need. And ultimately, what happens is we can produce X amount of energy. All right. Now, if we don't have an enzyme, compare no enzyme to if we do have an enzyme. Look at how much energy is required to start the engine per se. So if we don't have an enzyme, it requires a lot of energy. If we have the enzyme, it doesn't require as much. So these enzymes are really important because it allows these reactions to occur more quickly and with less energy put into them. And so enzymes lower that threshold, but enzymes sometimes also need kind of like a second key for them to work. And so as you read in your textbook and stuff, you might come across something called a cofactor. Okay, if we have an enzyme that requires a cofactor, but that cofactor isn't present, then nothing's going to happen. It's like the safety deposit box, right? So I don't have a safety deposit box. I've never actually seen one in person, but I've watched enough movies and stuff that generally speaking, there are 2 keys. The bank has one, and the person whose account it is has one. And you can't open this box without either key. And so it's the same idea. If I don't have the cofactor, it doesn't matter if I've got the enzyme because the enzyme's not going to work properly. All right, and so just another way to look at this. So the reactants are the substrate. We have to get over this wall. We have to get this over this. We have to generate enough energy, kind of like you have to use energy to make energy type thing. And so if we don't have that enzyme, it's going to take more energy. But if we have if we have the enzyme, that wall is lower and it's going to make it a lot easier for us to get that reaction going. Now, enzymes don't just go whenever. There's factors that can affect them. Okay, and the two that we're going to talk about are temperature. Okay, we talk about core temperature. It's one of the things that we measure. Well, and I'm going to show you a figure here in a minute that basically where we are at, our core temperature is in the sweet spot for enzyme activity. If we increase temperature too much, enzyme activity slows down. If we cool off too much, enzyme activity slows down. All right. Now, exercise does increase core temperature, and as long as it doesn't increase too much, this is actually a good thing. And we'll get into more about core temperature later on in the semester. But if core temperature increases too much, up to about 41 degrees Celsius, which is about 105 degrees, your enzymes become denatured. In other words, the shape changes and they're not able to do what they're supposed to do. As a result, enzyme activity is reduced. Okay, and then the other thing is pH. And remember, pH is just a measure of acidity or a measure of hydrogen ion concentration. So as we change pH, we also will decrease the activity of these enzymes. So again, going back to exercise causes us to become acidic. Okay, and that acidity reduces or lowers the enzyme activity, and there are consequences with that. So here, just to see this visually, so we've got core temperature on the x-axis, and we've got enzyme activity on the y-axis. Okay, 37 degrees Celsius, that's essentially what typical body temperature is. That's fine. We increase up to about 40, okay, and then once we get a little bit above 40, notice how fast the enzyme activity falls off. Okay, so really we're at the optimal location on this figure for enzyme activity. The same is true of pH. Okay, if you remember from your physiology class, we're generally at about 7.4, which will be right around this line here, which is really close to enzyme activity. We can become a little more alkaline or a little less acidic, and that will help us out, increase enzyme activity. But as we become acidic, so think about it, when we exercise, we become acidic. Okay, it doesn't have anything to do with lactate or lactic acid, which we'll talk about later. But we do produce hydrogen ion, and that hydrogen ion increases acidity, which decreases pH, and so enzyme activity decreases. Okay, and so that's where we're going to end for substrate and rate of energy production.